Yeah, good morning one and all. Once again, I'm going to start CO2 syllabus. The CO2 syllabus is being covered property cantilever as well as analysis of fixed beam. In property cantilever, what is the speciality? This is not a regular statically determined structure. It is a statically indeterminate structure. That means the required equations are not sufficient to analyze this beam. We need some compatibility equations. For that, we have to adapt the some different methodology and procedure. Say there is a one property cantilever is being given, fixed at one end, and prop means either it may be a roller or a hinge. When you provide that end, then it will become a property cantilever beam. A proper cantilever beam AB supports a uniform load Q. Determine the reactions, shear forces, bending moments, slopes and deflections. Choose RB as the redundant. Therefore, RA equals to QL minus RB, MA equals to QL square by 2 minus RB into L, and the bending moment of the beam is M equals to RA into X minus MA minus QX square by 2 equals to QLX minus RBX minus QL square by 2 minus RB into L minus QX square by 2. Then when we derive two times, that is M, that is nothing but a EI, M by EI, it is going to be a dx d square by dx square actually. So that is equals to QLX minus RB into X minus QL square by 2 minus RB into L minus QX square by 2. EI V dash equals to QLX square by 2 minus RB into X square by 2 QLX L square X by 2 minus RB into L X minus QX cube by 3 6 plus C1 and E8 B equals to QL X cube by 6 and RB X cube by 6. Then Q L square into L X square by 4 and RB L X square by 2 plus C1x Q X to the power 4 by 24 plus C2. Boundary conditions are V of 0 equals to 0, V dash of 0 equals to 0, V of L equals to 0. It is obtained C1 equals to C2 equals to 0, RB equals to 3QL by 8 and RA equals to 5QL by 8, MA equals to QL square by 8. Therefore, the moment is QL square by 2 8. That reaction is 5QL by 8. At B we have 3QL by 8. Then with that note, the shear force and bending moments are V equals to RA minus QX equals to 5QL by 8 minus QX. The diagram can be seen like this, and the diagram for the proper cantilever can be drawn like this. Then M equals to RA into X minus MA minus QX square by 2 equals to 5QLX by 8 minus QL square by 8 minus QX square by 2. The maximum shear force is Vmax equals to 5QL by 8 at the fixed end. The maximum positive and negative moments are M equals to 9QL square by 128 and M negative equals to minus QL square by 8. Slope and deflection of the beam, V dash equals to QX by 48 minus 6L to the power 4 plus 15 LX minus 8X square. V equals to minus QX square by 48 EI 3L to the power 4 minus 5LX plus 2x square. To determine the max, set V dash equals to 0 minus 6L square plus 15LX minus 8x square equals to 0 equals to 5.5785 L max equals to minus V x1 x of 1, then 0 equals to 0 dash 005416 QL to the power 4 by A. The point of inflection is located at M equals to 0, that is X equals to L by 4 less than 0 to and M A less than 0 for X less than L by 4 greater than 0 and M greater than 0 for X greater than L by 4. So that is the way we have to take the different types of numericals in proper cantilever problems. Proper cantilever with UDL, proper cantilever with the different point loads, proper cantilever with one single load, proper cantilever with a couple. Any kind of category problems can be seen and can be done like that. Then we can see here one more numerical, that is a fixed beam, end beam ABC supports a concentrated load P at the midpoint. Determine the reaction, shear force, bending moment, slopes and deflection. Because the load P in vertical direction and symmetric HA equals to HB equals to 0, RA equals to RB equals to P by 2, MA equals to MB, and M equals to PX by 2 minus MA, and 0 less than or equals to X less than or equals to L by 2 and EI V double dash equals to M equals to Px by 2 minus MA, and after integration it is obtained EI V dash equals to Px square by 4 minus MAX plus C1, and EI V equals to Px cube by 12 minus MAX square by 2 plus C1x plus C2, and boundary conditions are V of 0 equals to 0, V of V dash of 0 equals to 0, and the symmetric conditions. And the continuation of that one, V dash equals to V dash of 0 equals to 0, then the constant C1, C2 and the moment MA are obtained. C1 equals to C2 equals to 0, and MA equals to PEL by 8 equals to MB. The shear force and bending moment diagrams can be plotted. Thus the slope and deflections are V dash equals to minus Px into L minus 2x, 0 less than or equal to X less than or equal to L by 2, 8A. Then V equals to minus Px square 3L minus 4x 48A. The maximum deflection occurs at the center. Minus VL by 2 equals to PL to the power of 4 by 192 EI. The point of inflection occurs at the point where M equals to 0, that is X equals to L by 4. The deflection at this point is minus V into L by 4 into PL to the PL cube by 384 EA, which is equal max by 2 actually. So there is a numerical you can see here, simply fixed beam with 3 point loads is being given. Of course we can see here there is a method of superposition. How we can do this methodology: selecting the reaction reactants, establish the force displacement relations, consistence of deformation, compatibility equation, consider a proper cantilever beam, select RB as the redundant, then RA equals to QL minus RB, MA equals to QL square by 2 minus RB into L, force displacement relation, that is QL to the power 4 by 8A equals to RBL to cube by 3A. Compatibility equation: QL to the power 4 by 8A, RBL to cube by 3A, then RB equal to 3QL by 8. Then select the moment MA as the redundant, RA equals to QL by 2, MA by L, RB equals to QL minus MA by L, QL by 2. Then force displacement relation, QL cube by 24 EI and MA into L. Then compatibility equation, A1 minus A2, that is QL cube by 24 EI equals to MA into L divided by 3A. Thus MA equals to QL square by 8 and RA equals to 5QL by 8. RB equals to 3QL by 8. A continuous beam ABC supports a uniform load Q. Determine the reactions. Select RB as the redundant, then RA equals to RC equals to QL minus QL by 2. Force displacement relation, 5QL 2L by 4 by 384 EA, 5QL to the power of 4 L by 4 by 24 EA, then RB 2L to cube by 48 EA, RBL cube by 6 EA. Compatibility equations. then a equals to a1, then minus a2 a3 equals to 0, and b equals to b1 and b2. So up to this portion I would like to stop the today's class, and remaining portion I'll resume from the tomorrow's class. Thank you one and all.